Welcome. This is Exam Review, Exam Review Algebra 2, Semester 1. We're looking at problems 45 to 64. All right, so let's get started. All right, so we have our little exam review sheet. These are the formulas you'll be given on this exam. You got quadratic formula, and you have factoring of cubes, the sum of cubes, and the difference of cubes. All right, this is what we'll be given. We're going to put that on the side. Figure out when we need to use it. We'll have it there for us. All right. So problem number 45. All right, you should have your exam review packet out. All right, and it says for items 45A and 45 through 45C, grid in and bubble your answer in the grids provided. All right, so let's see what we can get done. A lot of this is done on the calculator. This problem is done on the calculator, but let's see. Problem number 45. The arrow is shot from a height of 32 feet with an initial velocity of 56 feet per second. The function for the height in feet of the arrow at time t in seconds is given by the function h of t is equal to negative 16t squared plus 56t plus 32. All right, so there's a lot going on in that problem, but the most important part of that problem is the equation that's given. All right, so let's see what we can do with this. This becomes a calculator problem. All right, almost exclusive calculator problem. So let's go to our calculator. All right, first thing we want to do is go to y equals and type our equation in. The equation given to us, negative 16. Instead of t, we're going to use x squared. We hit the variable button. X squared plus 56x or t plus 32. All right, we get the equation in, and what we want is a parabola. We want to be able to see how far up the arrow is shot, and we also want to be able to see where it hits the ground. So we're going to take a couple of little stabs at this. All right, x being our seconds. We can go from 0. We can start at, like, let's say 0 to 6. All right, we may be wrong, but we want to just try it out, see what we can get. All right, and shoot, scale was 1. All right, and our y min 0, and I usually just put in 100. All right, and we go from there and kind of see what it looks like, see what we get. All right, if we look at that graph, we can see its maximum value, and we can see where it hits the ground. And it looks like it hits the ground about about 4 seconds. Not sure yet. All right, but let's answer the questions. We got a good graph. Now, remember, if you don't see the whole graph, you wanna increase your x max, or you wanna increase your y max. All right, until you get a graph, you wanna mess with those numbers. All right, keeping your y min and your x min and your y min to 0. All right, so we got a decent window. All right, now it says after how many seconds will the arrow hit the ground? All right, meaning when will the height be 0? All right, and this is where we go to all our second calcs. All right, all our second calcs. So in order to do this one, we want to go to second calc 0. All right, so let's go. Second calc 0. All right, and like I said, it looked like it was about 4 seconds. Instead of scrolling, I usually don't scroll. I put a value a little less than 4 seconds, a little less than 4 in. So I may say for a left bound, I might say 2. All right, and for a right bound, I may say 5. All right, and it puts our little markers for our left and right bound. I don't want to guess. I want to hit enter, and it tells me right there that my 0. All right, the time it takes is 4 seconds. So at that, we want to go put a 4. and make sure you grid in. All right. For the next problem, it says how many feet high will the arrow be at 1.5 seconds? And there are several ways to do this. I'm going to stick with the second calc stuff. All right, so we're going to go second trace or second calc. All right, and we're looking for a specific value. So we hit 1. All right, so again, that's second calc 1. All right, second calc value. All right, and we just type in 1.5. All right, and at 1.5 seconds, the arrow is 80 feet high. So we go 80 and grid in 80. All right, you can put 80 here. I think you can put 80 there. Better just leave it like that. All right, what is the maximum height the arrow will reach? All right, so we're looking for this maximum value somewhere up here. All right, to get that, let's see. We're going to go second calc max. So all these, I just call this the second calc problem. All right, so we want to go second calc maximum. Now, the maximum, let me clear this out for a second. Clear. All right, the maximum looks like it's somewhere around 2. All right, so we're going to go second calc max, again, 4. All right, and we're going to say, well, it's definitely between 1 second. It happens between 1 second and 3 seconds. All right, and it puts my cursors at 1 and 3. All right, I don't want to guess. I want the answer. And the answer is, it says, what is the maximum height? So the maximum height is 81. And that would be 81 feet if we were right. If this was a problem where you didn't have the grid in, but we want to go 81. And we are done. Number 47. If f of x is equal to negative x squared, on what interval of x values is f of x increasing? All right, so first things first, let's get a graph of this. All right, most of us should know, some of us may not know what the graph of that parabola, since it's x squared, it's negative x squared, looks like, but it opens down and its vertex is through the origin. All right, so all right, if we graph this quickly, negative x squared, all right, and we take a look at what the graph will look like. So we're talking about the graph that looks something like that. All right, now, if the graph looks like that, we know that when we're reading a graph, it's increasing and decreasing. We're reading it like we read the sentence from left to right. All right. So if we look at this part, the part to the left of the vertex, it is increasing. All right. And once we get to the vertex, then it starts to decrease. All right. So we're really talking about the piece to the left. All right, so if we can just get rid of this for a second. All right, we want to say what this interval is. All right, and so this graph increases where x is less than to the left of the x value 0. All right, so that's going to be where the graph increases. Numbers 47 and 48 are left-end behavior, right-end behavior problems. All right, and so it's saying what are the left-end. 47 says what are the left and right-end behaviors of the function f of x is equal to x cubed minus 4x minus 8. Now there are a couple of different ways to do this. Since if this is a on-level regular Algebra 2 class, you're always welcome to type the equation in. Now, There are a couple other ways to do this, and we've looked at ways of doing this problem briefly. All right, but if we can get the graph, we see that this graph looks, for number 47, looks a little like this. All right, that's the basic, our basic curve in that graph. All right, and so if we're looking at our left end behavior and our right end behavior for this graph, all right, our LEB being as x approaches negative infinity, this graph will go down. So we say f of x approaches negative infinity. All right, our RAB, right end behavior, is as x approaches infinity, meaning as we go to the right, as this graph goes to the right, it goes up. So f of x approaches infinity. All right, for number 48, all right, for number 48, let me just zoom out a little bit. All right, as we look at this graph, it's a negative x, excuse me, clear, negative x caret 4 minus 4x cubed, math 3, minus 4. All right, and we can look at the graph. All right, and we can kind of see what happens with that graph. I'm not sure if you were able to see that, but the graph looks somewhat like this. All right, now, in a previous problem, in a problem we look at actually later, actually number 49, we'll talk about how we decipher the left end behavior and the right end behavior next problem. So I think these problems should have gone after number 49, but I didn't make this. All right, we go LEB, left end behavior. All right, as the graph goes to the left, the graph goes down. So we say as x goes to the left, or as x approaches negative infinity, f of x approaches negative infinity. And RAB, or right end behavior, we say as x approaches infinity, f of x approaches, it goes down, so negative infinity. All right. All right, number 49. A polynomial function has a general form, f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1, so on, where n is a positive integer. Describe the left end behavior for the following values of a sub n and n. All right, and so basically what this is that you only got 4 choices here. All right, and basically you can sum them up to either parabolas or lines, all right, with the slope. All right, so what we say, well, let's break this up. We have A, which is when the leading coefficient, all right, when the leading coefficient has a positive x to something even, that's A. you have B situation, all right, where f of x is, again, the leading coefficient is positive, x to an odd situation. You have C, which is f of x is equal to a negative leading coefficient, x, to an even exponent. And you have D, which is a negative leading coefficient to a odd exponent. All right, so basically this is what I said, all right, is that if we're dealing with an odd situation, we're going to look at a line to determine our end behavior. All right, if it's even exponent, even, let's say degree, let's just talk in degree, all right, because then that will determine our biggest exponent in the polynomial. All right, we want to look at a parabola for our answers. So we really don't have to use that graphing calculator if we can determine what our leading term is and then figure out whether or not the leading coefficient is positive or negative. All right, so those are your four situations. All I did was rewrite the problem. Now, if we're looking at for the even, all right, if it's even, we're going to look at a parabola, and what we're going to draw for an even positive is a parabola that opens up. All right. We just want to draw a parabola that opens up. That'll give us our end behavior. All right. Let me change some colors in here. Make it a little pretty. All right. So we're going to say it has to open up. All right. That's when it's even. All right. Parabola. All right. So here, if it's a negative leading coefficient and it's even, we're going to have a parabola that opens, you guessed it, down. All right. If it's odd, we're going to look to the line, and we want a positive slope line. So a positive slope line would look like this. And if it was a leading coefficient negative and its exponent odd, we want to draw a negative slope line. Now, if we do that, if we think of, this will take care of all of the end behaviors. All right, if we look at it that way, then we can determine everything else from there. All right, so let's try to do that. What we say is, for this one, and I know this is kind of tight, as x approaches negative infinity, as it goes to the left, f of x approaches infinity. It goes up. And as x approaches infinity, f of x goes up. So f of x approaches infinity. All right. Again, for C, since I'm just going to go across, both of the end behaviors go to negative infinity. So we say as x approaches negative infinity, f of x will approach infinity. Sorry for writing over that. And as x approaches infinity, f of x will approach negative infinity. Did I say negative infinity? I meant negative infinity for both of those because they both go down. All right, so to the left it goes down, to the right it goes down. It should be negative infinities for both of those. All right, for this one, and I'm just going to erase this now that we have our lines and parabolas out. All right, as x approaches negative infinity, as it goes to the left, all right, f of x approaches negative infinity again. All right, so as it goes to the left, it goes down. left down, and as x approaches infinity, f of x, so as it goes to the right, as x goes to the right, f of x or y goes up, so it's infinity. Alright, and let me erase this. And this one, as x approaches negative infinity, and I guess I should have been writing LEB and RAB, but if you look back at 47 and 48, you'll see that. Alright, so as x approaches negative infinity, f of x goes where? It goes up, alright, as we go to the left. So it approaches infinity, and as x approaches infinity, as it goes to the right, it goes down, so f of x approaches negative infinity. Alright, and so like I said, if you need to right now, I would probably rewind and take these, this little chart right here to do 47 and 48. Alright, so go back and look at 47 and 48. You could do it that way also. Alright, problem number 50. Some of the more straightforward problems in this semester exam review. They ask you to write a polynomial equation in factor form for the graphs shown below. Alright, so for number 50, if we look at number 50 and we take the zeros, alright, now you got to remember in this section, zeros, x-intercepts, they all mean the same thing. So, but for number 50, your zeros are negative 2, 0, 3, 0, and 6, 0. Yep. All right, and if those are the zeros, then you can come up with the factors of x plus 2, x minus 3, and x minus 6. And if you have those factors, then hey, we can write it in factored form. So we would just say f of x is equal to x plus 2 times x minus 3 times x minus 6. Alright, and we would be done. Alright, same thing for number 51. Alright, the zeros are negative 5, 0, 0, 0, and 4, 0. Alright, and so I'm going to write this 0 one first. Instead of writing, some people would write x minus 0, which is kind of silly to write. Just write the x. Alright, a 0 of negative 5 gives us a x plus 5, and 4, 0 gives us x minus 4. Alright, and that would give us our factored form. And you would be done. Piece of cake. Number 54. Oh, sorry. Nope. Alright, problem number 52 and 53. It says for these items factor. Alright, and in order to factor these problems, you want to go to your formula sheet and find your factoring of cubes, sum of cubes, and difference of cubes equation. Alright, now if we have those two equations, then we're good for this problem. Alright, so starting this problem, we have for number 52, we have x cubed minus 125. Alright, and we want to write 125 in terms of cubes, so we want to say x cubed minus 5 cubed. Alright, and if we're using our formulas, alright, we're going to use a cubed minus b cubed is equal to, plus b cubed is equal to a plus b times a squared minus a times b plus b squared. Alright, and so basically what we're saying is that a is equal to x and b is equal to 5. And so in order to do that, x cubed minus, oh, it's minus, sorry. So since it's minus, I apologize. All right, since it's minus, this is a minus and this is a plus. All right, there we go. All right, so if that's the case, we have x cubed minus 5 cubed is equal to, and we're just plugging in, x minus 5 times x squared plus x times 5 plus 5 squared. All right, and if we simplify that a little bit, that's x minus 5 times x squared plus 5x plus 25. And we're done. All right, for number 53, like number 52, or similar to 52, number 53 says 27x cubed plus 64. All right, and once again, we want to write 27 in terms of cubes, 27x cubed in terms of cubes, and 64 in terms of cubes. So that becomes 3x all cubed plus, excuse me, 4 cubed. All right, and that just means that our A is 3x and our B is 4. All right, 4. If we look at our formulas, the first one on your formula sheet for factoring, all right, that's A cubed plus B cubed is equal to A plus B times A squared minus AB plus B squared. Excuse me. And if that's so, then this is 3x plus 4 times 3x in parentheses all square minus 3x times 4 plus 4 squared. All right, and to simplify that, that's going to be 3x plus 4 times 3x is 9x squared minus 12x plus 16. All right, and you're done. All right, for 54 and 55, you need not only the factoring of cubes, sum of cubes and difference of cubes, but you also need quadratic formula because they are asking you to find all the zeros of each function. Now, another way of doing this is to do this problem like you do the other polynomials where you're finding all your zeros for each function. If you notice, there's only one real zero for this problem. The other two zeros are imaginary. So let's jump right into the problem. All right, most of you had this on probably your last test. All right, where for number 54, let's see, it's f of x is equal to x cubed minus 27. So we're going to do the same thing we did in 52 and 53. All right, but we're looking for the zeros in this case. So we're going to go x cubed minus 3 cubed. All right, we can keep the equal 0 out there for a second. All right, and remember we're using I'm using the factoring of cubes. All right, and so this becomes x minus 3 times x squared plus 3x plus 9. All right, and so go back. I skipped a step, but if you look at 52 and 53, you'll see how we got to this. Equals 0. Now, from there, we're using the zero product rule. X minus 3 is equal to 0, or x squared plus 3x plus 9 is equal to 0. All right. For this one, this is our real. All right, we get x is equal to 3. All right, and then for the other one, we need to use quadratic formula. All right, so we're going to say that A is 1, B is 3, and C is 9. All right, we're going to find the discriminant first, B squared minus 4AC. All right, that's going to give us 9 plus 4 times 1 times 9. All right, that's going to give us 9, excuse me, minus 4. All right, that's going to give us 9 minus 36, which is equal to negative 27. All right, now we know as far as our discriminant goes, if we end up with a negative answer, all right, we know we don't have any real solutions here, which we already should know from when we use difference of q's. This isn't going to give us a real answer. We have one real answer here. So let's finish this out. All right, remember we're doing x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this isn't one you're going to be able to get in the calculator because it's not real. All right, so this is negative 3 plus or minus the square root of negative 27 all over 2. All right, and that's your two answers. Now, as far as this square root of 27, negative 27 goes, you can reduce it quite a bit, but as far as I know, just taking the negative out of the radical will be far enough all over 2. All right, so that's two answers there. All right, so you got 2 answers here, 1 answer here, and it's x cubed, so you should have 3 answers. All right, number 55. We do that problem almost identically. And let's see that. Number 55 is f of x is equal to x cubed plus 1,000. All right, and we want to take 1,000 and make a cube of it, make it something cubed. All right, so that's going to be 10 cubed. All right, that means my a is x, my b is 10. All right, and we're going to use our formula. I guess I'll write it this time. I didn't write it last time. X cubed plus b cubed is equal to, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. All right, and so if we fill that right in with our x and 10, that's going to give us x plus 10 times x squared minus 10x plus 100. All right, that equals 0. Remember, we're solving for 0. All right, and we're going to use zero product rule again. That's x plus 10 is equal to 0, or x squared minus 10x plus 100 is equal to 0. All right, quadratic, so we say a is equal to 1, b is equal to negative 10, c is equal to 100. All right, and let's do it. All right, we got b squared minus 4ac, which is going to give us 10 squared, which is 100, minus 4 times 1 times 100. That'll give us 100 minus 400, and that's equal to negative 300. All right, so gave us a negative answer for the discriminant, which it should. All right, let's finish this out. X is equal to negative b. Here, let's write it all out again. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so when we finish this. This is x is equal to a negative 10 is a positive 10 plus or minus the square root of, we already figured this out, negative 300 all over 2 times 1, which is 2. All right, let's see if we can finish this. All right, we'll go x is equal to 10 plus or minus I root 300 all over 2. All right, we could definitely reduce that more. Last time I checked, that's going to be okay. But if we're asked to reduce that more, we can take a factor of 100, square root of 100, so we could make this 10 plus or minus, square root of 100 is 10, so 10i root 3 all over 2. All right. Because of that, having to simplify the radical, this isn't likely to have. You usually don't have. That's not a skill that you have to accomplish on the final. Usually, for what we do, that one would be enough. But that's a little step further. All right. So we got our 2 complex, but we need to go back and do our real, which is x is equal to negative 10. That's your real 0. So there's the whole problem. All right.